OpenAI says its unreleased model solved 10 math problems that humans could not. The proofs are real. A machine checked every line. And then, quietly, 45 hours later, somebody edited the sentence. On August 1st, OpenAI announced Astra by skipping the benchmark charts entirely and publishing a 249-page maths paper. 10 results: high-dimensional geometry, group theory, quantum complexity, lattice cryptography, including the first construction of a non-sofic group, a question left open since 1999. Total compute cost, they said, about $2,000, which is less than most companies spend on a team off-site where nothing gets solved at all. So is this the moment maths got automated, or the moment marketing got a PhD? Today we read the receipts, the archive, and the fine print. It is August 13th, 2026, and this is the AI Code Report. Start with the part that is genuinely, boringly true, because it matters. OpenAI did not just publish prose. They published Lean proof certificates on GitHub, Apache licensed. Lean is a proof assistant. You write the argument in a language so pedantic that a computer can check every step, and it will refuse the whole thing over one gap. It is the least charitable reader in the universe. In Lean, an unfinished step is literally the keyword sorry, so the fastest audit in mathematics is counting the sorries. 548,000 lines, 0 sorries, 0 custom axioms. That means a machine that does not care about anyone's valuation checked these proofs and did not complain. Whatever else is true, that part is not a press release. It gets better for them. A researcher at Anthropic reproduced 5 of the 10 inside 24 hours using a public Claude model, autonomously, no internet. A graduate student independently got result number 4 with a public model too, which is a strange kind of flex. The headline is that an unreleased frontier model did something unprecedented. The footnote is that the models you can already rent did 5 of it before lunch. So the maths is real. Now for the bit that is not. On August 1st, the announcement said these were problems that had seen, quote, no progress on the main result for at least a decade, and in most cases much longer. By August 3rd, that same sentence read, 10 results, each of which resolves or makes substantial progress on a long-standing open problem. Read those twice. No progress for a decade became make substantial progress on. The first sentence says nobody had moved. The second sentence quietly admits somebody had. I pulled 18 snapshots of that page from the Internet Archive myself. The change lands between the evening of August 2nd and the morning of August 3rd. There is no correction notice. There is no change log. The sentence simply grew up overnight. And there is a reason that specific sentence was load-bearing. Scientific American reported that mathematicians whose earlier work fed these proofs were not credited. One of them said the team was running roughshod over the work of others who came before them in a deliberate way. OpenAI's response was that they take responsibility for correctness and would make small updates to the paper. The paper then grew from 249 pages to 253. The abstract was rewritten to name 2 prior mathematicians, and those same 2 were newly thanked. Small updates. To be scrupulously fair, nobody has shown that any of the 10 proofs is wrong. The Cambridge mathematician most annoyed about the framing went and built on the result, which is the most sincere compliment a mathematician can pay. His actual complaint was the big PR machine that wants to sound as impressive as possible. Now, if this feels familiar, it should. In October 2025, an OpenAI vice president posted that GPT-5 had found solutions to 10 previously unsolved problems from a famous open problems list. It had not. It had found papers where they were already solved. The database maintainer called it a dramatic misrepresentation. The head of Google DeepMind called it embarrassing. The post was deleted. So the pattern is not that the model lies. The pattern is that the number 10 keeps arriving before the caveats do. Terence Tao named this directly in January. He pointed at the strong reporting bias against disclosing negative results, and then estimated that on those famous open problem lists, the genuine success rate is on the level of a percentage point or 2. Nobody publishes the 99. And OpenAI has confirmed there were failures here too. They just have not said how many, on which problems, or at what cost. But here is where this stops being a dunk video because the usual comeback no longer works. For years, the reassuring line was that competition maths is not research maths. An Olympiad problem has a guaranteed answer, a fixed toolkit, and 90 minutes. Research has none of those. A real problem might be false, might need a technique nobody has invented, and might take 9 years instead of 9 hours. That argument was correct. It is also in 2026 mostly retired and not by the hype men, by the skeptics. One mathematician who spent years publicly calling this stuff overhyped bet in 2025 that AI could not autonomously write top-tier papers by 2030. He gave 3-to-1 odds. This February, he wrote that he now expects to lose that bet. Another, who wrote that Olympiad problems were a million miles from real research, wrote last month that large AI-generated developments in mathematics are now inevitable, and ended the post with "What a time to be alive." A mathematician who won a Fields Medal this year put it flatly: very shortly AI will become robustly superhuman at what professional mathematicians currently do, and he mostly wants people to grapple with that reality. Which means the argument has moved. Nobody serious is still asking whether the machine can touch research mathematics. What nobody can explain is why a company holding a genuine result felt the need to oversell it by exactly one sentence. And the answer is probably in the filing cabinet, not the lab. In March, OpenAI closed the largest private funding round ever recorded, $852 billion post-money, and the announcement justified it by pointing at accelerating scientific discovery. In June, they confidentially filed to go public. Astra's maths landed in the middle of that window. As Terence Tao put it at this year's International Congress, when a measure becomes a target, it stops being a good measure. He then named the financial incentives of AI companies as exactly why. One more wrinkle. 6 days after the announcement, OpenAI slowed Astra's release over cyber capability concerns. So the model that allegedly did research mathematics is a model nobody outside the building can test. So, the verdict. The proofs look real, the formalization is the strongest receipt in this entire story, and the mathematicians who spent 2 years being right about the hype have started changing their minds in public. The claim did not need help. It was already the most impressive thing an AI lab shipped this year. Somebody edited it anyway, and that edit is now the only part of this that is definitely false. And if you want one number that explains why the lean part matters so much, here it is. On a study of frontier models answering maths problems, one leading model reached the right final answer while producing a proof that did not actually hold up about 40% of the time. Right answer, broken reasoning, stated with total confidence, which is also a fair description of most code review. The practical lesson is the one Lean has been teaching for 40 years. A claim is a vibe, a proof is a thing a machine can check. Ship the second one. This has been the AI Code Report. Thanks for watching, and I will see you in the next one.